Today our focus is on sedimentary rocks, and again our essential questions are describe the steps to create a sedimentary rock, and then we also want to go and give the environmental history of that rock. So what happened in order for that rock to appear, and you're going to be able to use your lab, your rock key for that, so good to go. So sedimentary rocks are, there's a couple different varieties of sedimentary rocks. We've got clastic, chemical, and organic, and hopefully you recognize this picture as the Grand Canyon. It is one of the most well-known locations for layers of sedimentary rock, and we can see within the Grand Canyon all these different layers that have appeared within the earth, and the layers really gives us a good clue that that's most likely going to be a sedimentary rock formed there. Now the most common type of sedimentary rock is this one here, clastic, and that's where we're going to start. So if you could locate that on your notes, star, circle, highlight, underline that spot where it says clastic sedimentary rocks. It's kind of tucked in there on top. So find that. That's where we're starting today. We will then move to talk about chemical and organic, all within the sedimentary family. Now what I want you to notice about the name sedimentary rock is what it starts with. The word sediment is right in there. So what a sedimentary rock is a rock made completely of, you guessed it, sediments. Sediments are tiny little pieces of rock. So basically a rock made up of little rocks. That's what's happening here with a sedimentary rock. A sediment, again, is a tiny, small piece of a rock. And just like we saw with igneous, there is a process that goes into making this type of rock. It's a little more detailed than the igneous rock. Okay, so step one is weathering and erosion. Okay, weathering is really describing how rocks are broken down. You haven't heard these words before, maybe you want to jot down their definition on the side there. Weathering is the breakdown of rocks. Erosion is then the movement of those pieces. Right? And there's a lot of different ways that rocks can be eroded. Think about what happens on the surface to move rocks. Wind, water, ice. All kinds of things are moving these little pieces of rock around. So that is step number one. The breakdown of rocks and then the movement of those little pieces. So what we see is solid rock broken down or broken into smaller pieces of rock. And like we said, we call those small pieces of rocks sediments. Now this is happening all over the Earth's surface. And we can see kind of in this picture here a bunch of different ways that rock can be broken down. And once it's broken down, it then becomes eroded. And like we said, that's the movement of the rock. So then it becomes transported to a brand new location. So we have the mountains here, for example. Got the mountains here. Okay? In order for them to be weathered, what kind of natural things would happen to that mountain face to cause weathering? Okay, we've got a few things happening in the picture. We've got some rain going on. We know wind can sometimes break rocks apart. Here's a river. That's something that can break rocks down. Once it's in the ocean, waves can crash around, break it down. We have here some snow, ice, glaciers are responsible for erosion and weathering of rocks. And even gravity, right? Gravity can pull rocks down, cause an avalanche, cause them to break up and be transported. So that's what we're looking at here with weathering and erosion. The original rock gets broken down into small pieces and then it's moved about the Earth's surface by some of those natural forces that we discussed. Now for step two, we have to have those rocks land someplace new. Okay, they become deposited somewhere. So step two is our deposition step. What happens is the sediment, or those tiny pieces of rock, they start to settle. Right? They've traveled through by the wind, by the rain, and they find a new location. It's usually a low elevation, right? Because we know rock and water don't travel uphill. So we know it's normally a low elevation, and typically we see in a marine environment. And marine is basically a fancy way of saying a water environment. Okay? And because the water has different flows to it, what we normally see is that the sediment then starts to be organized by grain size. So if it's a really strong flow, I usually tend to have rocks that are bigger. If it's a slow-moving, gentle flow, it can't carry those big rocks, and we tend to see just small grains within that water environment. So they do get organized depending on the speed of the water in that environment. So again, looking at my picture here, we want to come up with a place, 3 places minimum, where we can actually have those sedimentary rocks start to form. And there's a lot of names on here. Some of them are fancy. But think about, where's a place where you see water gather, right? Minnesota, definitely we would start to see sedimentary rocks form in lakes or along rivers, swamps, a beach. Okay, way out here on the continental shelf or the slope. Way out here in the deep ocean basin. Okay, there's lots of different locations where that sediment can start to collect and deposit. Now as we continue, the conditions need to be just right in order to get that rock to form. And here we approach now step 3, compaction and cementation. Okay? Once all that sediment has been deposited in a new marine environment, it starts to pile up. And the more the sediment piles up, the more pressure increases. Okay, so as those sediments start to pile one on top of the other, the more material that piles up, the more pressure there is on those layers underground. And once that pressure builds up, they begin to compact. Right? That's our first word here, compaction. Those tiny little rock fragments start to push closer and closer together as more and more sediment starts to pile on top. And when enough sediment piles up on top, we end up having a glue-like substance form in between the grains, and we call that material cement, right? And so this cement works like a glue or a cement to keep those sediments together. Okay, so this would be a zoomed in picture of some sediments at the bottom of a lake or a swamp, a stream, a beach, and we can see this kind of yellowish material in here in between the little pebbles and stones. That is the sediment. Okay, it's like a mineral glue that keeps all those pieces together. And over time, that cement becomes hard enough to solidify all those pieces into a rock form. So a couple examples of a classic sedimentary rock. Again, classic sedimentary rock is made up of sediment pieces of other rocks. So we can clearly see the pieces of other rock in this one. They are very large. Here's a hammer for scale. A lot of time in geologic pictures, they'll put something in there so you can tell how big or small the item is. But these are big pieces. We call this one conglomerate. You'll see a picture of that today, or an example of that today. Okay, we're also looking at this one here. We don't so much see the grains. It is very small. You might recognize this one as sandstone. We've all seen sand before. This one, the grains are sand size, whereas here they're almost fist size, right? But we can see the cement holding that rock together. That's pretty cool. Over here, the sandstone, with our naked eye, we can't see those things, but with a microscope, the cement would be visible. Our second type of sedimentary rock here is chemical. Okay, a chemical sedimentary rock is a little bit different. It's made from minerals that precipitate from a solution. And again, a solution means a water type of environment. So minerals would precipitate or form right out of a liquid type of environment, when either an organism is making a shell, or most commonly, they get left behind when the water goes away and evaporates. Alright, so we can kind of see that happening down here in this image. Got the bottom of a lake here, or a shallow sea. Over time, parts of that water can evaporate, leaving behind the salt crystals to then form and sink down to the bottom. So sometimes within these rock layers, the clastic rock layers, we can get a chemical rock layer formed in there from the water, the minerals left behind when the water evaporates. So predicting a place where chemical sedimentary rock would form, we said a lake would be an example. Basically anywhere where water is and then sometimes can go away from. So here's a little tidal pool here. We also see a picture over here of Death Valley, and I know that probably didn't come to your mind when you were doing a prediction, but it is a pretty cool place. Temperatures there get nice and toasty, so any water that runs down from the surrounding mountains oftentimes gets evaporated, which leaves behind a fair amount of minerals there on a regular basis. The third and final type of sedimentary rock is organic. Okay? An organic sedimentary rock is going to contain something that was once part of a living thing. Okay, and I know all the time that means our brain goes right to bones and stuff like that. I want you to think plants here. Okay, plants is probably our most common type of organic material inside of a rock. Oftentimes, because sedimentary rocks are being formed in these marine environments where plants are prominent, like a swamp, we tend to have plant matter as one of our common materials to make it organic. Coal would be an example of that. But sometimes we can see remnants of living things, like shells. But every so often we have the actual substance, but we're thinking small, like bacteria or even plankton. Okay? So an organic sedimentary rock is going to have remains of a once living material, either a plant or a very small organism. It is important to note that a fossil does not make an organic rock. Just because there's a footprint of something within a rock does not mean it's in the organic category. So a couple examples here. We can see this one. The main ingredient here is clearly shells. This one is called coquina. We've seen one similar like that today. This one we've seen before in class when we talked about renewable, non-renewable resources. This is peat. And peat is step number 1 to making coal, both of which are organic rocks. Organic sedimentary rocks. Now as we get to the back side, we're starting to think about our lab. In order to figure out the environments that the rocks are coming from, we're going to use this table. This table has 3 parts to it. It's got environments, it's got sediments that make up the rock, and then the rock that would form. So in a swamp environment, the typical sediment or material rocks are made of there are dead plant remains. Okay? And within those dead plant remains, one of the most common rocks we get there would either be coal or peat, the ones that we just saw a picture of there. In terms of a beach or near shore environment, you can probably predict the sediment there is going to be sand and sometimes bigger pieces like pebbles. So one of the rocks I can have would be sandstone. Another would be conglomerate. And that was the one we saw that had the large pieces with the hammer in it. So it's similar to sandstone, made up of pieces of sediment, but just larger sized ones. In a shallow sea or coral reef, now we're getting out a little bit farther, so we don't have as big of materials. We can't hold the pebbles with the current out further in the sea. But because we're in the coral reef environment, shells come into play. So that coquina is a possibility, as is a rock called shell limestone. And finally, out in the deep ocean, far from shore, again, our current is slowing way down, so our particles become very small, mud particles, clay particles. The main rock I'm looking at here is called shale, has very fine grains in it. So now that I have my table complete, I can start taking a look at the 5 sedimentary rocks we're going to see today: sandstone, conglomerate, shale, limestone, and then shell limestone, which is going to be like that coquina. Okay. As we go through the rocks, again, I want you to start here underneath the rock name, give an observation of how you think the rock looks. So tell me, what can you see in it? What does it remind you of? Is it a certain color? This is your observation. Okay, maybe it's non-scientific, but it's got to be some kind of observation, so start there. Once you have your observation done, then you are going to use your diagram to complete the made of sediments and the environment. So you're going to find the rock on the previous table, work your way up, figure out what environment it was in. Was it a swamp, a beach, a coral reef, or a deep ocean? And then what sediments would be found there? Would it be pebbles, mud, plant materials? Again, using the diagram. The process here, similar to the igneous rocks, it always has to go through the same steps. So you are going to fill in deposition, compaction, and cementation for each of these zones. Without one of these steps, the sedimentary rock could not occur. So all 3 steps are required in each box to show the process needed to take the sediments into becoming a rock. Finally, once your rock views are complete, you've got 2 summary questions to finish up. One of them, describe all the steps of sedimentary rocks. Do not just list them. Describe what is happening in them. Okay, you've got a little space there on the front of the page. And on the back page on the bottom, you are going to do 2 of the 5 rocks that you looked at in the lab. And again, using your lab chart, make a sentence using all the boxes and just read from left to right. So tell me, starting with what sediments, go then into the environment. So sand in a beach environment goes through deposition, compaction, cementation to form, and then end with the rock type. And again, do that for 2 of the 5 that you viewed in the lab.